I'm Youyou Cong at Tokyo Tech. I will be talking about a variation of refinement types that can be used for counterpoint composition and beyond. Refinement types are a powerful tool for expressing program specifications. A refinement type consists of a base type, which describes the shape of an expression, and a refinement, which is a sequence of predicates describing the detailed properties of the expression. As an example, suppose we would like to define a type tau representing a non-empty list of integers whose head is a non-zero number. Such a type can be represented as a refinement type whose base type is list int and whose refinement is a conjunction of the non-empty and non-zero head requirements. Under this definition, a refinement type checker will tell us that list 123 is an inhabitant of type tau, but list 012 is not. In a traditional refinement type system, refinement predicates are uniformly treated as mandatory requirements. This is reasonable in situations where we use refinement types to describe specifications of programs, because for a program to be correct, it must fully meet its specification. However, the uniform treatment is problematic in situations where we use refinement types to describe specifications of music, since music has a rather vague notion of correctness. For example, when writing a melody in the style of the common practice period, it is preferred but not required to start and end with a tonic note, where the tonic is the first note of a scale. So, in the specification of a C major melody, we would have two predicates representing non-mandatory requirements. Correspondingly, when deciding whether a melody is good or not, we would make a graded judgment rather than binary one. To express vague correctness of music, I propose weighted refinement types. The idea is to associate every refinement predicate with a weight representing the importance of that predicate. By building a type system based on this idea, we can guarantee musical soundness, that is, highly weighted music does not sound wrong. So far, I've developed a weighted refinement type system for composing species counterpoint, and that is the main result I would like to share with you today. Okay, so species counterpoint was developed by Johann Joseph Fuchs as a method for teaching multi-voiced composition. There are 5 species of counterpoint differing in the complexity of the rhythmic structure. Among them, we are going to focus on the first species, which is the simplest one. Here is an example of 2-voice first species counterpoint. On the bottom, we have a fixed melody called cantus firmus, and on the top, we have a counterpoint line. As you can see, both voices have exactly one whole note in each bar. Counterpoint has a set of rules, including mandatory ones and non-mandatory ones. This example adheres to both groups of rules, so you should find it well-sounding. Now, let's look at some examples that break the rules. This example breaks 2 rules that are mandatory. I believe that you all found this example not as good as the previous one. So what is wrong with it? The first problem is that it uses a 4th interval, which is considered dissonant. In first species counterpoint, dissonant intervals cannot be used anywhere in the composition. The second problem is that it has a direct 5th, that is, a 5th interval that appears in a context where the 2 voices move in the same direction. In counterpoint composition, direct 5th and octave are strictly prohibited. We next listen to an example that breaks a non-mandatory rule. This example sounds odd, but probably not as bad as the previous one. The issue is that we have a chromatic note, a note that is not a member of the C major, in the counterpoint line. Chromatic notes are allowed in counterpoint, but they do not make sense in all contexts, so they are generally not preferred. And here is another example that breaks a non-mandatory rule. Again, the counterpoint doesn't sound great, although it is not too bad. The issue is that we have repeated notes in the counterpoint line. Like chromatic notes, repeated notes are not disallowed, but they tend to make the composition boring, so they are not recommended. That's some of the basic rules of first thesis counterpoint, and I designed a language in which we can reason about the correctness of counterpoint using types. In this language, counterpoint is represented as a non-empty snark list, and each bar is a tuple of a pitch and one or more intervals. The composition rules are represented in the form of a weighted refinement type. So here is the list representation of our first counterpoint example. It is constructed from left to right by extending the singleton list of the first bar with subsequent bars. The elements of the list are pitch interval pairs, where the pitch is a note in the cantus firmus, and the interval is the distance between the two notes in the bar. And here is the type representation of composition rules. It is a weighted refinement type that has two groups of refinement predicates. These predicates encode rules on a single bar and rules on two adjacent bars, respectively. The weights on the predicates represent the reward or penalty. In particular, when the weight of a predicate is minus infinity, the predicate represents a mandatory requirement. With these design principles in mind, we can interpret the type here in a straightforward manner. The first group of predicates prohibits dissonance, encourages imperfect consonants, and discourages chromatic notes. The second group prohibits direct fifth and octave, encourages contrary motion, and discourages repeated notes. Having seen the representation of counterpoint and its rules, we look at the typing rules that connect these representations. In our language, we use a special typing judgment for lists, which has a weight telling us how correct the counterpoint is. To see how the weight is computed, let's observe the rule for typing a singleton list containing an expression E. Here, we check which predicates in the first group, psi 1, are satisfied by E, and sum up the weights of those predicates. We then use the sum W1 as the degree of correctness of the singleton list. The rule for an extended list is similar. Here, we additionally use the second group of predicates, psi 2, to evaluate the progression from the previous bar to the newly added bar. And we include the sum W2 in the total weight in the conclusion. One thing I would like to note here is that proper evaluation of counterpoint is much more complex, but for now, we just take this simple additive approach. Okay, so let me show you how the typing rules work for our counterpoint examples. This is the most correct one. On the top, we have the weights associated with rules on individual bars, and on the bottom, we have weights associated with rules on adjacent bars. Since this example does not break any rules, the summands are all positive numbers. We next look at a bad example. This example has a dissonant interval and a direct fifth, which are both prohibited and thus associated with a minus infinity weight. Therefore, the overall weight is also minus infinity. Now we type an OK example. This example uses a chromatic note, which is not preferred and hence has a small penalty. So the overall weight is positive, but it is lower than the weight of the first example. From these examples, we can conclude that although our evaluation is naive, it gives a higher weight to better counterpoint. So our type system is consistent with the slogan, highly weighted music does not sound wrong. Okay, so far I have talked about how to use weighted refinement types to evaluate counterpoint. At future work, we intend to use this idea to synthesize counterpoint. We believe that this can be done by extending existing type-directed synthesis techniques with weights. In addition to this, we would like to explore programming languages applications of weighted refinement types. A possible application would be optimization problems, like the famous ski rental problem, where we have various weighted constraints. Using weighted refinement types, we might be able to express those constraints at the level of types and thus ensure the optimality of the computed solution. Okay, so in this work, I proposed an extension of refinement types that is useful for counterpoint composition and potentially for programming as well. What we can learn from this is that a type theorist may get inspirations from a non-programming domain, like music and other kinds of art. I believe that the FARM community will discover more interesting type systems in the future, and I look forward to learning about your discoveries in the future editions of the workshop. Thank you.
Hi, my name is Alistair. I'm going to be talking today about a functional EDSL for mathematics visualization.
Hello? Oh, all right. I think we needed a minute or two to readjust the sound. Is that correct? Okay, so please think of your questions for a second, and we'll get Youyou attached. She's online, but we need to fix up the sound.
Youyou, can you hear us? Great. Okay, cool. I think we're good to go.
All right. Are there any questions?
Hi, Youyou. This is Steve Taylor from Illinois. I just have a couple little questions about the counterpoint rules. In the example you have with the A flat, in the first species where it's like A flat to B to C. When I learned counterpoint, if you had an interval of a augmented second, I think that would be negative infinity just for me.
So in my current implementation, I just treat the A flat. So we don't distinguish between is it minor third?
It sounds like a minor third, but it's spelled like an augmented second.
Yes, we don't distinguish between them.
Oh, okay. Well, never mind then. Yeah, sorry. That's it. Neat. I liked it.
Mm-hmm.
Hi, Yo-Yo. Audrey So, University of Washington.
Mhm.
I'm just curious, what would be the benefit of using, like, also very cool work, but I'm just wondering what would be the benefit of using weighted refinement types and type-directed synthesis versus something like, I don't know, MaxSat or other SAT like optimization techniques.
Mhm. Yeah. So the benefit is that in my approach, we can statically guarantee the kind of correctness of counterpoint, right? Because we have all the constraints at the level of types. If we just implement these constraints at the level of terms, then you can't view the counterpoint as the proof that it is correct.
Okay. Yeah. Thank you.
Thank you.
Hi, Youyou. May, we've talked a lot. I was curious if you have any answers for counterpoint rules that require looking at more than single intervals at a time. For example, the famous horn fifth does allow you to approach a fifth by parallel motion, but that's just because it's so dang cool when it resolves in the next step. Is that something that your system can take into account?
Can you repeat your question?
So horn fifths. Let me take my mask off 1 sec. It's a very muffling mask. My apologies. The horn fifth is a sort of classic counterpoint maneuver where we're in the middle of it, we're going to approach a fifth, an interval of a fifth, by parallel motion, which normally would be banned in traditional counterpoint rules, but is usually added as an exception because people liked it even in the 16th century. This has an interesting character because you actually need to look at the approach and the resolution in order to determine whether that should be weighted as positively or negatively. Is that something you can encode in your system?
I didn't know that rule, but I think if we can extend the rule for extending lists to look at a more global structure, maybe we can handle that kind of constraints.
Thanks.
Thank you.
Hi, Youyou. I'm Charlotte. I'm from Worcester Polytechnic Institute, and I was just wondering. So counterpoint obviously is a very strict set of rules that are, and there are absolutes. But in many other styles of music, even classical outside of counterpoint, contemporary music and especially jazz is defined often by its rule breaking. And I was wondering if your system could instead be modified to kind of reverse the rules and see, like, does this actually meet some kind of negative requirements? Like, does it not have too much harmony?
Yeah, that's an interesting question. So far, I'm just considering this very strict setting. And I'm not sure if my approach is good for those kind of more contemporary compositions. But I'm interested in exploring that.
Thank you.
Hi, you May again. Sort of in the vein of the last question, I'm wondering if your weights are configurable, if I could easily take your system and adapt it by changing the rules a little. Let's say instead of being Palestrina, I wanted to be Carlo Gesualdo.
I think that would be easy. So currently, in my system, we need to manually adjust the weights of various predicates, and you just change the weights, and then you will get a different rule system.
Awesome, thanks. We still have a couple of minutes. More questions?
Hi, Yo-Yo. Really cool work. Thank you. I'm Amy from the University of Washington. I know you just said that you didn't really think about other types of contemporary composition when you were designing this, but I was really curious to learn if you had used your rules to try to weight different pieces of music, like if you had taken known counterpoint works and taken their weights and maybe compared them with the weights of other types of works. And I'd be curious, especially to hear if you could detect a sort of adhesion to the counterpoint rules or sort of counterpoint-ness in works that are not, designed with counterpoint in mind. And all this just to say, have you tried evaluating or getting scores for pieces of music that have already been composed?
So so far I have just tried strict counterpoint. Let's see. So I don't know. This is part of my future work, I guess. I think there's a lot of work on composing other genre of music in the machine learning community, and I believe that they still use some kind of weight for that line of work. So I can probably borrow some ideas from that kind of work.
Thank you.
Hey, Youyou, I promise I'm not trying to ask every other question. And we do have 5 minutes, so plenty more time for questions if any people find late breaking. I'm not sure if we have a way to ask questions online. But if we do, we should check there to see if there are any. So if you're on Discord and wondering why we haven't gotten to you, we forgot to look. Our apologies. I have a question about the various species of counterpoint, and in particular, the weighting. So in addition to their different aesthetic qualities, there are just literally more intervals in species 2 or 3 counterpoints. Do you have a way of sort of weighting the program so that I get a score that is based on the overall goodness, but not influenced by the length, not influenced by the actual number of intervals in the program?
I don't think I understand the question.
Well, it looks like it's a straight addition right now. So if I had a perfect species 1 counterpoint composition, and then I added 2 more measures, the score would go up. Is that right?
Yes.
But if I'm comparing 2 pieces of counterpoints and I want to know which one's more idiomatic, the length of the piece tends not to matter for whether it is idiomatic or not.
No, but there are some rules specifically for the beginning and the ending.
That's certainly true. I'm just wondering if it would be easy to convert the system so that the score is invariant with respect to the number of measures in the middle. If I add 3 measures in the middle of perfect counterpoint, I don't change my score if it was already perfect.
Yeah. So in that case, maybe my current list-based approach doesn't work very well. I think John has some thoughts about that, so we can ask him.
I talk to John sometimes, so yeah, I can do that. Thank you.
Yeah.
All right, we have one question on the Discord from Liao Xia. It says, what might a more elaborate weighting scheme than adding weights look like?
Elaborating weighting scheme. I'm not sure what it means.
All right, maybe if Liao can add something to the question to explain it a bit more. Meanwhile, as we have a couple minutes, I do want to say I've worked with you before, and of course looked at her current work, and I maybe she's being a bit modest, but I think for a lot of these extensions and handling more contemporary stuff, I believe it's definitely doable in her system. Once you handle higher species counterpoint, you're already looking at more global things, so that will handle some of May's things, and I think the contemporary music and so forth can be handled by adjusting weights in different ways. So I do believe this has a lot of promise for more advanced use as well.
Thank you.
All right, so it looks like Liao is typing in something here, which hopefully
Yeah.
we'll see soon in a second. There's another question in the meantime.
Hi, Matthew Lutzi, Aarhus University, Denmark. I'd like to know if you've thought about how to integrate this with music composition software to act as kind of a linter for composers.
Wow. So initially, I was trying to extend the synquit synthesizer, which uses refinement types to synthesize functional programs. So I wanted to extend that system with weights and compose music. But yeah, it would be interesting to create something that can actually help people compose correct counterpoint.
Thank you.
Okay, I see Liao's text.
All right, do you see the question? So he says that you mentioned that you just added weights together, and that was probably simplistic. I was wondering if you had already had some thought into more realistic rules to evaluate counterpoint.
Yeah, so there is a study on using dominance relation for composing counterpoint. I still don't fully understand that work, but that is a more kind of realistic or serious evaluation of counterpoint quality. So one way to do that is to encode their rules as types.
All right, I think we're out of time, but I think it's, 1 a.m. or 2 a.m. there in Tokyo. So thanks very much, Youyou, for staying up late to answer all of the questions. Wonderful questions for everybody. Fantastic talk. Let's thank you for her talk.
Thank you.
All right, and I hope you get a good night's sleep.
Yeah,
all right.
Good night.
Thanks very much.